This is another question from JEE Advanced 2023 exam. So here we try to find the roots for this equation here involving with the trigonometries. Involving with trig function here. The square root of 1 plus cosine 2x equals square root of 2. The inverse tangent or arctangent of tangent x. Right? Of course, with the specified range. All right. So let's look at the problem. This arctangent is defined. The range is going to be negative pi over 2 to pi over 2. Right? Of course, s is a real number. And we have this equation here, and we're interested in the solution of this equation. And in this interval here, because tangent x is not defined over pi over 2, right? So that's open intervals here. All right, so let's start with this equation here, okay? Cosine 2x equals square root of 2 tangent, arctangent, right? The inverse of tangent. Now, for the quantity here, does it equal to x? All right, let's think about that, right? First of all, we noted that this whole thing here is going to be in this interval by definition, right? Now, x may not be, right? So in other words, let's call this alpha. By definition, alpha is going to be in this interval. However, tangent alpha is going to be equal this part, equal tangent x. And tangent function is periodic with period pi, right? So which means alpha is in this interval, but x does not have to be, right? So x in this case would equal to alpha, which is in this range, plus k pi, where k is an integer. So let's rewrite this equation now. Now for this left-hand side here, this quantity, you should know that is actually using the trig identity here, is going to be 2 cosine square x. And if you put a square root, you're going to get square root of 2 times cosine x absolute value, because cosine x could be positive or negative, equal square root of 2 and alpha. And x and alpha are related by this. All right. So with this equation, what can we do? All right. Of course, let's cancel square root of 2 here. So we get cosine x absolute value is going to be equal alpha, where x has to equal alpha plus minus k pi, right? Or plus k pi, right? You can just, because k can be negative integers here, right? So now what you can do is you need to know what is cosine x. Excuse for the bad drawing here. Let's assume this is a function of cosine pi, yeah. And if you want to get absolute value, then you flip selective value here. Okay, so what you can do, 3 pi over 2, negative pi over 2, negative 3 pi over 2. Let's look at this equation here, right? Now we're gonna fix x in this interval here, and in that case, x will equal alpha, right? So cosine alpha equal alpha. So this equation becomes, because cosine alpha is positive here, equal to alpha. So you know that y equal x. This is the y equal x equation here. So the intersection point here is going to be the solution. All right. So in other words, we have found a solution here. Okay. This is once we find one, then in this interval here, we're going to find with plus multiple integer pi, right? So if you plus pi here, so somewhere here is going to be pi, and this is going to be, and somewhere here, right, is going to be negative pi plus alpha. So the total three solution, which is the alpha, let's say this is called alpha 0 here, right? So the alpha 0 satisfies this equation, and alpha 0 plus pi, and alpha 0 minus pi, right? So the answer to the original problem is that we have 3. The number of real solutions over this interval here are marked as in the diagram. Let's review some of the key points in solving this problem. First of all, we need to understand the definition of arctangent, right? The value is going to be limited in the primary range of negative pi over 2 to positive pi over 2. So if alpha equals this, then tangent alpha equals tangent x, which means x is going to be alpha plus multiple of pi, where k is an integer here, right? Another thing we need to use is the trig identity for double angle formula, cosine 2x equal 2 cosine square x minus 1, or equal 1 minus 2 sine square x. So it's very commonly used formula. In this case, we are using this fact. 1 plus cosine 2x was in the original equation. We turn that into 2 cosine square x. All right, so that's some of the key points. All right, hope you enjoyed the video. Please like, share, and subscribe to the channel.